Hello everyone and welcome to the chapter 6 of TMUA Simplified. Today we'll be doing transformation and dilation reflection of graph. Now these things are very important from TMUA point of view because a lot of questions will be solved through understanding of dilations and transformations and reflection of graph. Right, so let's start. Okay, so when I say transformation of graph, so let's take an example. Suppose I say I have a function y is equal to fx is equal to x square. Now I know the graph of this is this, right? Now if I have to find the graph of, suppose f of say x plus 1, right? So that is the case of horizontal transformation. Here the transformation is happening in x. So when and x axis is horizontal, so that's why the transformation will be horizontal. But where will it be? So let's understand again through horizontal transformation. So I have this graph and this is of fx, y equal to fx equal to x square. So for f of x plus 2, the graph will be x plus 2 whole square. The graph will be x plus 2 whole square. So where will it go? So we need to see that initially the graph, the value of y equal to 0 was at x equal to 0. Now when will it be 0? Like if I put it equal to 0, so I'll get x equal to minus 2. So this vertex or the minimum point of this graph, which is parabola, will move to this point, and this will be minus 2 comma 0. So you can see that the graph is same. The only thing is that it has moved to, or it has transformed horizontally or moved to the left hand side by 2 units, right? Similarly, if we have to find the graph of x minus 1 whole square, so if I say f of x minus 1 will be x minus 1 whole square. Now for this graph, if I put x minus 1 whole square as 0, right, I will be getting x equal to 1. So the vertex or the bottommost point of this parabola has moved 1 unit to the right. 1 unit to the right. So the same, it will remain same. The figure will remain same. The only thing, or the graph will remain same. The only thing is that it will move to 1 units on the right because the transformation is in x, right? We are replacing x by x minus 1. So the transformation is happening in the x direction, and that too on the positive direction, because on putting x minus 1 whole square as 0, I'm getting x as 1, right? So this is what you have to understand. So if we generalize and if I say fx is the graph, suppose, so the graph of y equal to x plus a will be horizontal transformation, or the graph will move to the left by a units, and the graph of y equal to f of x minus a is graph will move to the right by a units. So there is no change in the shape of the graph. The only thing which happens is the transformation, or you can say movement, horizontal movement towards the left or towards right, depending on what is there in the bracket or what I am replacing x with. That is what it depends on, right? So this is called horizontal transformation. Now suppose we talk about vertical transformation. So if we have a graph, the same graph, y equal to fx equal to x square. Now the transformation, or if I say what is the graph of fx equal to x square plus 2. Now I can see then when x was 0, y was 0. Now when x is 0, y is 2. So everything remaining same. Now the transformation is happening in say y, because y was x square. So x square plus 2 means the transformation is happening in y, and y is vertical axis. So the movement will be vertical. So the graph will move by 2 units up. So everything remaining same, the graph only will move by 2 units up. That's the only difference, right? And if we have a function fx equal to say x square minus 1, then the graph will remain same. The only thing is it will move down by 1 unit. So this point now will be 0 comma minus 1. So this is how the graph looks like. You can draw the graphs on a graphic calculator also, if for your understanding, more understanding of it. So you can see the shape of the graphs will remain same, right? The only thing is the transformation is happening in x or y. So if I generalize, if we have a graph of y equal to fx, so y equal to fx plus a, if we have a graph, so the graph will move a units up. And if we have a graph y equal to fx minus a, then graph will move a units down. Shapes will be same, ditto same. The only thing is there will be a movement in the vertical direction, a units up or a units down. So this is what transformation of graph is, or translation of graph is, right? So it is translating, or it is transforming, right, up or down, right? So just a brief generalization. If I say fx ka graph, if we have a graph of fx, so graph of y equal to fx minus a will be a units to the right. Y equal to f of x plus a is there. The translation is taking place in x. A units to the left. If there is a plus sign, so they will be left. If it's a minus sign, it will be right. Y equal to fx plus a. Now the translation a is outside, so transformation is taking place in y. So a units up, vertical transformation or translation, and y equal to fx minus a. So I'll say a units down. The graph movement will be a units down. Everything will be same. So if you remember these four things, you know, it will be very easy for you to translate the graph. Like for example, suppose I say we have a graph y equal to mod of x plus 2 minus 3. Now, if I see there is no, there is only transformation or there is only translation, there is no change in the shape of the graph. The reason, there is no coefficient of x, there is no change in the degree of x. So I know the graph of mod x is this. This is the graph of mod x. Now, since this is the graph of mod x and we have plus 2 and there is a translation in x. So for plus, it will move to the left, and minus 3, this is translation in y, so it will move down. So the shape of the graph will be same. The only difference, it will move to minus 2 and will move down. So the graph will be like this. The same shape of the graph, but now it will be at minus 2 comma minus 3. Right? So this is how we can translate or transform the graph very easily on the left hand side, right hand side, up or down, right? Now let's move on to stretching or dilation of graph. Both means the same thing, stretching or dilation. Again, stretching the graph is like, suppose we have a graph like this, and the same graph, it becomes a little flatter, so it has stretched, or it has, if it becomes a little, say, compressed, right, like this. So in both the cases, the graph is getting stretched or dilated. Now the graph is changing, it's not same, right? Mind you that it's, but it is dilating, it is stretching. So let's first talk about vertical dilation. So suppose I have a graph of y equal to fx, any graph. So for example, suppose I say y is equal to fx equal to x cube. Now the graph of x cube I know is this. It moves like this. But if I say what is the graph of y equal to twice of fx, now I know that every y coordinate will increase by a factor of 2. So every y coordinate is increased by the factor of 2. So at 1 when the at x equal to 1 initially y was 1. Now at x1 y will be 2. 2 into 1. So at 1 if it was 1, now at 1 it is 2. So the movement of the graph will be like this. So it will be closer to, it will move closer to the y-axis. The graph moves by, or it by a factor of 2, but it moves towards the y-axis. And similarly, if I have y is equal to half of x, so now I know that the graph is moving, but at 1, now the value is not 1, it is half. So at x equal to 1, y is half. So I know 1 at it will be half. So the graph will be like this. So it will be moving away from the y-axis by a factor of half. So this is how I have to understand this. So the graph of twice of fx, or if I generalize, so if we have a graph, y is equal to fx, right, any graph, so y equal to afx, right, so graph will move, right, uh, it will be a vertical dilation by a factor of 1 by a, or factor of a, sorry, vertical dilation by a factor of a. And if I have y is equal to 1 by a of x, then there is a vertical dilation by a factor 1 by a. So if a is a natural number, if I say if a is a positive real or a value say more than 1, suppose I say a is greater than 1, so vertical dilation by a factor of a closer to y-axis and vertical dilation by a factor of 1 by a away from the y-axis. So as we saw the graph earlier, so through that we can understand this. So this is what we mean by vertical dilation. So if we have a factor which is a times fx, so every coordinate of y is changing. So for x will remain same. So for every x values, initially whatever the values were, now they will be increased or decreased depending on what is a. So if a is greater than 1, so all the values will increase by a factor of a. So there will be a vertical dilation or a stretch, vertical dilation or a stretch by a factor of a, which will be closer to y-axis since a is greater than 1. And if it is 1 by a of x, then again it will be a vertical dilation, right, but away from the y-axis. So it will be away from the y-axis. So this is something which you have to understand, right? Okay. Like, suppose to give you another example, suppose I say y fx is equal to say 4 minus x square, right? So the graph of this will be, I know it will be like this, and the roots will be 2 and minus 2, minus 2 0 2 0, right? So this is how the graph looks like for 4 minus x square. Now if I multiply, if I find for 2fx, so for 2fx the graph will be 8 minus 2x square. So the roots will remain same. It's only that the roots are same. If you put it equal to 0, roots are values of x where y is 0. So if I put it, so roots will be still be -2 and 2. But this point will move up because y values are increasing by 2. So initially it was, see, if I put x as 0, this was 4. Now it will be twice of it. So the graph will be like this. So it will move up, or you can say towards the y-axis, or all the y coordinates will increase by a factor of 2. So this will give me, roots will remain same. So this will give me 0, 8. 0,8. So this is how the graph looks like if I have two fx, just to give you an example. Right. Now, suppose we talk about, say, horizontal dilation. So horizontal dilation takes place, suppose we have a graph of y equal to fx is equal to mod of x. So I know this is the graph. So if I have to take a graph of y equal to fx equal to mod of 2x, now the factor is inside the mod, inside the function, or you can say y equal to, sorry, my bad, just a minute. So it will be like y is equal to 2x, f of 2x, which is mod of 2x. Now here I can see that whatever the value of the graph or for the function was at x equal to 1, right, this, now it will happen at half because 2 into half is 1. So whatever f of 1 was initially, x equal to 1, y was 1. Now the same value of y equal to 1 is at x equal to half. So I can say now the graph has become like this. So it has compressed a bit. So it is dilated in the direction of x-axis, right? So this is how it looks like. So it is dilated by a factor of 1 by 2. All x values will become half. That means whatever the values of y were initially at different values of x, all those values of y now will be achieved at half values of x when x has become half. So I would say whatever the value for mod x, y value for mod x was at x equal to 1, now the same y value 1 will be at x equal to half. So it has dilated horizontally by a factor of half. But if I have y equal to x by 2, so it will be mod of x by 2. Now, whatever the value of y at x equal to 1 was, now it will be obtained at x equal to 2. So at x equal to 2, it will be 1. So now at 2, it will be 1. So the graph is like this. So it has moved horizontally, but it has stretched a bit, right? In the previous case, it compressed a bit in the x direction. Now it has stretched more in the direction of x. So you can say it has dilated horizontally by a factor of half. And initially, it has dilated by the factor, sorry, by the factor of 2, sorry, my bad. For mod of x by 2, it has stretched or dilated by a factor of 2. And here, in the previous case, for this, it has dilated horizontally. Horizontally is the word. Horizontally by a factor of half. That means all x values become half for the same y values initially. So that is what you have to understand. So if I generalize, so if we have a graph of y equal to fx, so y equal to f of ax means the graph, if a is greater than 1, the graph has dilated by a factor of half horizontally, by a factor of 1 by a horizontally, and for y is equal to f of x by 2, x by a, the graph has dilated or stretched by a factor of a horizontally, right? So this is how we look at the dilation of graph, right? I hope you understood this pretty well. Right, now let's move on to reflection of graphs. So when I say reflection of graph, now reflection of graph means reflection happens in two axes, either x-axis or y-axis, or it can happen in the line y equal to x. So if I say y is equal to fx, suppose there is a graph for it, and suppose I say the graph is like this. So if I say what is the graph of y equal to f of minus x? So f of minus x, it means reflection in the y-axis. Reflection in the y-axis. So let's start it. So if I have a graph of like this is the graph of y equal to fx. So the graph of y equal to f of minus x will be reflection in the x-axis. So to understand this, I know reflection will be like this and this. So the new graph will be, the new graph will be like this. So this is the graph of f of minus x. So whatever the graph of fx is, y equal to f of minus x graph means reflection in the y-axis. So this is how we understand graph of or reflection in the y-axis. Right. Now let's talk about reflection in the x-axis. So if I say y is equal to fx as a graph like this, as I draw again. So y equal to minus of fx means reflection in the x-axis. Simple. So if I reflect this, if I reflect the same graph, so it will be like this in the x-axis. So the graph of this will look like this. So this is what we have to understand. Very simple. It's the concept of reflection. Very, very simple. Not much of a problem. You have to just see where the reflection is taking place. Right. Now, last thing is reflection in the line y equal to x. Now, reflection in the line y equal to x means the change in the nature of x and y. So reflection in the line y equal to x means the x coordinate becomes y coordinate for the whatever the initial function is. Suppose y equal to fx is the initial function, and for this suppose we have a coordinate a comma b. So now it will be reflected here. So it becomes the x coordinate, y coordinate becomes the x coordinate, and the x coordinate becomes the y coordinate. And this is also called the process of finding inverse of a function, also known as finding the inverse of a function, right? So this is what reflection of a graph is. So for example, if I say y is equal to fx is equal to x plus 2, right? So the graph, if I have to reflect this graph in the line y equal to x, so I need to find function first. So if y is equal to x plus 2, what I will do is I'll make x the subject. So x becomes y minus 2. Now I interchange x by y and y with x. So this will be x minus 2. And this is called f inverse x. And this is the reflection of the graph y equal to x plus 2 in the line y equal to x minus 2. So if I plot, say this is y equal to x. If I plot y equal to x plus 2, so it gives me y equal to x plus 2 will give me, if x is 0, for y equal to x plus 2, if x is 0, y is 2, and if y is 0, x is minus 2. So if I plot these 2 points, for x 0, y is 2, and for y 0, x is minus 2, which is here, so this becomes this line. Now I know the reflection of this will be y equal to x minus 2. So y equal to x minus 2, as I told you, is also called inverse of a function. So if I plot this y equal to x minus 2, so right, so for x equal to 0, y is minus 2, which is this point, and for y equal to 0, x is 2, which will be this point. So this is the exact reflection of the green line in the yellow line. So yellow line is y equal to x, green line is y equal to x plus 2, which was my original function, and this is the inverse function, which is y is equal to x minus 2. So this is what the meaning is in terms of y is equal to a reflection in the line y equal to x, right? So that's all about transformation, dilation, and reflection of graph, right? There are questions at the end of this chapter. Please do that, and there are video solution of that chapter towards the end also, right? Take care. Have a nice day.